Hi girls. So it doesn't look like we're going to be back anytime soon. Definitely not on the 29th. It doesn't seem to be, from what the media is saying. So I was intending on holding these calculations till I met you. This is kind of the last major section. I know I have those two other experiments of the recrystallization of benzoic acid, which I've put up now. I'm waiting to see your attempts back on that. Some of the stuff, girls, I'm putting up, I'm not getting attempts back, and I'm not going to continue to do videos on them if I'm not getting attempts back. So that 2015 question one that you're supposed to attempt, I still haven't had enough attempts back to do a video on that yet. You need to be trying them. I need to see what mistakes you're making to be able to fix those mistakes. Okay. But I'm going to start to go through these worksheets. So this is a worksheet that I gave out to you the week just before we left school to start at Working Try. There's 25 examples and basically covers most of the math type problems that you can get on the exam papers. This normally highlights the ones that you have issues with, and we can come and take a look at them. So the first couple, the first one, and I've put the answers up. I sent that through Microsoft Teams because it's in my OneDrive, so it's a little bit easier. So I have given you this answer sheet which has the methods all done out for you as well, and you're more than welcome to just take a look at that if you're happy with the questions. But this video will deal with maybe question 1 to 7, etc. 1 to 7, and then we'll break it down. This is on the front, and this isn't by any means for everyone, and you've seen yourself that in the last while they've kind of gone away from using formulas. But for students who are still struggling with calculations of moles, sometimes these can help at this point in time. So this one, for example, is the number of moles is the mass divided by the molecular weight. And there's a couple of little formulas like this. If you're planning on using them, come back and let me know, or if you're struggling individually, so if you send me a private message, and I will do you an individual video on how to use those formulas. I don't use them in class, I never have done, and never will do, because they don't help with the understanding. But at this point in time, when you're this close at 6th year, if you're still struggling with calculations, they can sometimes give you just a way out, even if it means you mightn't necessarily understand what you're doing. At this stage, you're just trying to get as many points as you can, so we can change the method if we have to. Okay, so the first couple here is calculate the relative molecular mass, the molar mass. And most people think that those calculations are exactly the same, but they aren't. So the relative molecular mass, if you think about it, it is the relative mass of 1 mole. So to get it, you go to the mass of each individual part of the compound. So for example, O, you go to the periodic table, you look it up, it's got a mass of 16, and there's 2 of them, so it's 2 by 16 is 32. What you notice with relative molecular mass is there are no units. And there are no units because if I take a mole and I weigh it, it doesn't weigh grams. Okay. The molar mass is the thing that weighs grams. So what we're saying is if you take a whole mole of that, it will weigh 32 grams. But you'd have to take a whole mole of them, which is 6 by 10 to the power of 23 molecules of it, which is a huge number. So when you're asked for relative molecular mass, there are no units. And it has never happened, but there's nothing stopping them asking that type of question, asking you to work out the relative molecular mass, breaking it down for you. Often they'll think they're helping, but if you put a unit there, you are incorrect. Okay, whereas the molar mass, then you're going to the periodic table as you would always do, but it does have a mass. So each mole is measured in grams then, so your grams per mole. And you can see that the units are there. Again, in converting between grams to moles, we've been doing this for 2 years now, and you don't really have a difficulty with it. If I'm taking a look at that question, how would I do that question out? So in terms of the sulfuric acid one, so I'm looking at number 3. So how would we go about doing that? We wouldn't use a formula. So sulfuric acid sales are used to market, and it's 2.45 grams. So 2.45 grams were weighed out in a beaker. How many moles of acid is this? So you're looking to convert 2.45 grams of H2SO4, and you're looking to convert it to moles. So we would always write down 1 mole, and we would work out what 1 mole of sulfuric acid is, and that's already worked out for me. It's 98 grams. So 1 mole is equal to 98 grams. We would always then come down to 1 gram, so it's 1 divided by 98, and back up to 2.45. And 1 over 98 multiplied by 2.45. And from the exam's point of view, this is really how they want to see it. But you could just use the formula on the front page. So that's mass divided by molar mass, or what a molecule weighs, if you have a mole of it, and you get 0.025, and you get the same answer. And it'll carry you for most questions. It won't carry you for all of them. Again, example 4 is very, very similar. So this time you're told that you have 1.5 moles of stuff, and it's NH4NO3, and you're asked what mass that's going to be. Okay, so again, the same starting point is how I've always done it. So you work out what 1 mole of this is. So it's 14 plus 4 plus 14 plus 3 by 16. So where are those numbers coming from? Again, periodic table and the atomic masses. So that adds up to 80 grams. So 1 mole is equal to 80 grams. You didn't have 1 mole, you had 1.5 moles. So you convert it here by multiplying by 1.5. So you're going to multiply this side by 1.5, and you will get 120 grams. Okay, and that's the way we've always done them. But again, if you take a look at the answers, I've used the formulas in these cases just so that any of you who are still struggling at this point, and this is something I would do at every group of sixth years, if you're still struggling, there are ways around your struggles, okay? And you don't have to not be able to attempt a question. Example 5, converting mass to number of particles. So again, you are looking at, the first question says 3.65 grams of HCl, and you're asked for the number of molecules. So you're asked for how many molecules. Okay, so you're taking a look at the formula now, so you know that 1 mole of this will have 6 by 10 to the power of 23, and this is Avogadro's number. Okay, you have it in grams, and you need it to be in moles to be able to use this formula. Okay, so there's no way of directly going from here to here. You have to change this one into moles first. So you're writing down what 1 mole of HCl is. And remind yourself again that HCl is the weird one, where you have to take in Cl as 35.5. Okay, that one, copper and iron, just copper, I think it is. Yeah, it's just chlorine and copper that you have to take the decimal point for their mass. Okay, so you didn't have 36.5, you had 3.65. So using the method you had for question 3, you're going to be 1 divided by 36.5 multiplied by 3.65, and you're going to have 0.1 moles. And now you can go back up and use this formula. Okay, so you don't have 1 mole, you've got 0.1 moles. So it's going to be 0.1 moles is equal to 0.1 multiplied by 6 multiplied by 10 to the power of 23. All goes into the calculator, and you get 6 by 10 to the power of 22. So it's 6 by 10 to the power of 22 molecules. Okay. Converting the number of particles then back. So this time you're looking at example 6. And example 6 is asking you to go the other way. So a silicon computer circuit has 1.22 by 10 to the power of 20 silicon atoms. What mass is a silicon atom? Okay, so again, you're starting the same way. You're going 1 mole is equal to 6 by 10 to the power of 23. And you're trying to find out how many moles of silicon atoms you have first, then you'll convert to mass. So you have to go through moles when you're using this formula. Okay, so I don't have 6 by 10 to the power of 23. I want to come down to 1, so that's the usual way, 1 divided by 6 by 10 to the power of 23. And then I want to go back up again. So I want to go to 1.22 by 10 to the power of 20. So it's 1 over 6 by 10 to the power of 23 multiplied by 1.22 by 10 to the power of 20. At this point, make sure that you can use your calculator, okay? Because these are numbers that you're not used to using. So I would always, when I'm doing it, I would always just use the fraction button, and I'd put my 1.22 by 10 to the power of 20, and I'd have 6 by 10 to the power of 23. You can do it loads of different ways, but just to make sure that you're doing it in some way, shape or form like that, okay? And that gives you 0.000203 moles. Okay, so again, if you take a look how they do it in terms of this one, they're doing it the same, they're getting the same answer, so that answer looks completely different. Sometimes the calculator will give it back to you in by 10 to the power of 4. It's the same thing because you're moving the decimal place 4 places. 1, 2, 3, 4. Okay, so it's the same answer, it just looks different, and depends on the mode you're in your calculator, how it'll give it back to you. It doesn't really make any difference. And then you're looking at, well, 1 mole of silicon weighs, because the question asked for it in grams, okay, so you've got to make sure that you're giving it back to them in grams. So 1 mole of silicon is equal to 28 grams, and again, I'm getting that from the periodic table. I didn't have that at 0.00203 moles, so you multiplied here, so you're going to multiply here. So it's 28 multiplied by 0.00203. And when you type that in, you're going to get 0.00567. I'm just going to multiply it now here by 28 and make sure, because I'm just reading it off the thing now. Yeah, 0.056 across the line. Okay. So that's converting, that's number 6, and then converting moles to litre is STP. So question 7 is asking you calculate the number of litres of gas, hydrogen sulfide in 1.25 moles at STP. So you've got 1.25 moles of hydrogen sulfide, and it's at STP. So you need to know what STP is. STP is standard temperature and pressure. Okay. And there's a molar volume. Now this one is always written at the front part of your exam script. So on the very front of your exam script, it'll always tell you what number they want you to use for STP. There is a different number at STP, which is standard temperature and pressure, than there is at room temperature. So it depends on which one you're going. At STP, 1 mole is worth 22.4 litres. Okay. It's 24 litres at room temperature, so it's normally 1 mole is equal to 24 litres, and it'll tell you at the front part of your paper on that very front page what numbers they're asking you to use, so just make sure you're looking at that. Didn't have 1 mole, had 1.25 moles, so again I'm multiplying, so it's 1.25 multiplied by 22.4, and that is 28 litres. Okay. Occasionally, what you'll see with those questions then is they'll ask you to take back a look at converting that to, we'd say, centimetres cubed, or instead of giving it to you as 22.4 litres, it'll be given to you as 22,400 centimetres cubed. Whatever unit they want is the unit that you'll use. To go from a litre to centimetres cubed, you're multiplying by 1,000. So that'd be 28,000 centimetres cubed if they asked me for that. Okay. So that's what the work we would have done when we were in 5th year. So that would have been the very first experience that you would have had here in chapter 9. So chapter 9 would cover all of those type of questions. So if we go and take a look now, chapter 9 will take a look at some questions that you could give a bash at. I forgot to bring home my workbook. So we would have used the workbook to do these questions, which we've already used. So it's probably a better idea that you go and take a look at using your textbook now, because we never used it when we were in 5th year. So these are new questions for you that you won't have seen before. So if I'm taking a look down here, we're starting at molar mass. So we'd say 9.3. 9.4, 9.5, 9.6, 9.7, and 9.8. So if you do 9.3 to 9.8 for me, and I'm going to put this up as an assignment, and I'll put it up on Monday. So let's say I'll give you a deadline. We always had class on Tuesday, so you can have it done for me for Tuesday afternoon, because I think our class is normally an afternoon. So if we do Tuesday afternoon as the deadline for that, and this will take a look at those calculations. Again, I would recommend this only for the higher level girls. So if you're doing ordinary level, I've already given you different work, so I would take a look at that instead. Okay, Talk to you soon. Take care. Bye.